the purpose of this short video is to demonstrate the code that you're going to write to build your Arduino scope. Now, in a previous video, I've walked you through the breadboard prototype to install what we call the trigger button for your Arduino scope and connect your probe to the analog output line A0. And so now we're going to look at the code necessary to actually read your analog values from your oscilloscope onto your computer monitor. To do this, we're going to use the serial plotter that's available within the Arduino IDE. So I want to first walk you through how to load the serial plotter, and that is under the Tools menu of the Arduino IDE, and then look for serial plotter. Another thing you can do is on the Mac, it is Command-Shift-L. And when you type Command-Shift-L, it'll bring up the serial plotter. And so my code is already running on my Arduino, so I'll walk you through what's going on here. So this plotter, if you've ever used an oscilloscope before, you've seen an oscilloscope in another video, this will sort of look familiar, right? You have some signal that's changing and it's moving past the screen. And on the bottom of the screen, unfortunately, it's not easy to plot this versus time, but we have basically samples along the bottom axis or the x-axis. And then the y-axis is actual voltage measured by your probe or analog input A0. And so on your probe, you see that we're reading values between 0 and 5 volts. And we'll talk about how we got to that point in a bit. So right now, rather than talk about the signal that you see on the screen, I want to walk you through the various lines of code that go into making this happen. All right, so if we look over here to the right side, we see that the very first line of code, I've defined a constant integer button pin. And if you remember from the previous video, when we wired our button into the digital I/O port of the Arduino, we wired it to digital I/O 2 or pin 2. And so we've defined this here now, is that we're going to be looking for the button state on digital I/O pin 2. And the next line is not necessary for the oscilloscope functionality of what we're doing, but it is necessary for the signal that you see on your screen right now. So I'm using the Arduino not only as the scope, but also the signal generator in this case. So I'm generating a PWM signal on pin 9. On digital I/O pin 9. And so that's what's defined here with this second line constant. Then after this, there's 4 variables that are defined. A double value for old value, a variable value that's also a double, an integer for the button state, and a double for the probe value. So I've kind of got a lot of values thrown around there, but we'll see how those variables are used when we get down to the loop part of the functionality. Then the setup function is pretty simple. We are calling the serial begin function, and we're applying a baud rate. Okay, and so I'm not going to get into the details of the baud rate here, other than to say that this is how quickly the signal on the screen gets plotted. So if I increase this baud rate, we'll basically take more samples or show more samples per second on our screen. Okay, and then we're setting the pin mode as input for the button pin because we're reading the state into the Arduino. And then the PWM pin where we're setting as an output because we're generating that signal and putting it out of pin 9. Okay, so then within our loop function, now this is the function that's going to repeat on the Arduino. This is where we put our main code that will run in a repeated fashion. And so the very first thing that we have here is writing out the PWM signal. And notice that I say I'm going to have values between 0 and 255. And the reason for that is the PWM signal is an 8-bit output, essentially. So we can generate values between 0 and 255. But if you're familiar with PWM, you probably are thinking, well, I normally think of PWM in terms of percentage, right? And so in terms of percentage, you have to do the conversion here for the Arduino API. So to use the analog write, it takes values between 0 and 255. In our case, we have 25 there. If I change this value to 127, which is halfway between 0 and 255, and I re-upload my code, what we're going to see is that the signal now has changed shape a little bit. Rather than being like a skinny peak, it's actually a quite nice square wave. And I'm going to preview what we're going to talk about in a second, but if I pause the signal, you can see that roughly half the time this signal is high, or 5 volts, and half the time the signal is low, or 0 volts. And so that's because I've set the value halfway between 0 and 255. Now, if I set the value to 255, I can rerun this. And now you see that the value of the output, or the value measured by our oscilloscope probe, is at 5 volts. And so that's what we expect. And if I set this to 0, then we're going to measure 0 volts. Now there's a transient there when we restart the program, but now you see 0 volts. Now we'll go back to the point where I had earlier, which, why don't, instead of doing 25, why don't we do 250? So that's almost 255. And what we see there is that 250 still looks like 5 volts to our analog input pin. Okay, so let's dial it back a little bit more. So let's say 230. And so now if I pause it, you'll see that the signal is most of the time at 5 volts, but only a little bit of time it'll drop down to 0. And that's because we've set the percentage very high, right? 230 out of 255 or 256. Okay, so I'll let that run as we go through the rest, but that's how you generate a PWM signal. Now, I should state that, again, if you're just using this program for an oscilloscope, you don't need that line of code there. You could be measuring signals from something else with your probe that you have attached to analog input A0. So I'm just using this to generate a signal that I have something to measure that'll move across the screen. Okay, so what are we doing to pause the thing? Because you can see now the signal is just whizzing past, and it's really difficult to kind of see it. So it's nice to be able to just click a button and pause. And if we need, we can take a screen capture of this and look at it more closely to try to analyze the signal. Or if you need to turn this in for a class, you can do that. So how do we utilize the button that we put on our prototype board to be able to do this? So that's what the remaining lines of code are all about. And so the next step here, highlighted in yellow, is to read the digital I/O pin 2 and get the state of the button. So when the button is pressed, this button state will now go high, okay? And the next line, and I should say, and when the button is released, the button state will return back to low. So if I press the button, it'll go high and we pause, and I release the button, it goes low, and we start the signal back up again. Okay, the next line is reading the probe value. And so this is where we're doing the analog input read on analog input A0. And to just read that value, you just call this function analog read and give it the parameter A0. But we want to scale this to some value that is between 0 and 5 volts. Well, the analog read if you look at the API, returns a value of a range of 1024. So it goes from 0 to 1023. And in order to be able to scale that, all we need to do is multiply by 5 divided by 1024, and that'll scale the signal down to fit between the 0 to 5 volt window. Now, you want to be careful that you make this a double when you're doing this, right? So if you divide 5 by 1024 without the 0.0 or without typecasting, you might cancel out your signal there. So be careful. But we're trying to put this into a double, so we want to use a double here when we're doing this division. Okay, so now we've read our button state and we've read the analog voltage that's coming in. How do we get that onto our screen? Well, how we get that onto our screen is very simple. And how we get it onto our screen is to call the serial.println function. And when we call serial.println and provide it the value that we're reading, then it shows up on this, this screen, okay? Now, what we really want to do, though, is stop doing that when we get to a signal that we want to look at. And so rather than just having it continuously print, I want to read the button state. And if the button state is high, I want to set the value to the old value. So whatever the previous reading was from the button or from the analog input, I want to store that. And then and stop printing, okay? Because notice that the thing that you see here on your screen only gets updated when we do a new serial print line, okay? So by putting the serial print line in the else statement, when we press the button, we're now not in the else statement, but we're in this statement, right? And so then there's nothing being printed to the screen, and we just see what was there before we press the button, okay? But as soon as I release the button, then the value will start updating again. I just realized that I don't think I even need this value equals old value. I've been playing with this a bit. To simplify our code, we'll change it on the fly mid-video. So now, only if the button state is low do we print something out, and otherwise we just stop, okay? So let me rerun this, and this will simplify several lines of code from our, actually we don't need value and old value. And we just need to put in probe value here. Okay. So now let's put that to our Arduino. And so now we see that it's going past again. And when I press the button, we pause. Okay, so that's very simple now. I've even simplified it further. So that's all it takes. So if you want to build your own oscilloscope, these are the simple steps that you can take to do that.